P naught is equal to 1 into minus 3 divided by 2. It will be 0.5 into minus 10, 10 power minus 3 Newton per meter square. P naught is equal to B K S naught. S naught is equal to P naught divided by BK. Bulk modulus given.
Yes, sir. 1.2.
This is your formula.
So when we solved this question, we got confused with S naught and amplitude. No, when we solved the question in school, sir, the S naught will completely forgot that it was amplitude.
Now, who is that? They were asking me some other question. What is it?
Sir, I sent you one question the other day. It was in waves chapter. Taking the elemental strip one.
Can you resend that?
Yes, sir, 1 minute.
If it's from the material, tell the page number and question number.
Sir, it's from exercise 3, question number.
Let's look at that question, everyone.
Oh, yesterday's this thing.
Read out the question.
So,
Read the question.
a rope hangs from a rigid support. A pulse is set by jiggling the bottom end. We want to design a rope in which velocity v of pulse is independent of z, the distance of the pulse from a fixed end of the rope. If the rope is the desired function for mass per unit length, mu z, in terms of mu naught, which is mass per unit length of rope at the top, where z is equal to 0, is given by.
B is independent of.
So,
B is independent of.
z.
What is it?
The distance from a fixed end of the rope.
1 3. So probably Z is length of the rope, right?
Yes.
So we have given a jolt here. So the waves started going like this. So I'm going to take a small element. For this small element, first I will do the analysis. So a small element is dx, right? So the mass of this will be mu,
Mu into d.
right?
Yes, sir.
For this, there is a tension which is acting upwards, isn't it?
Yes, sir.
Element here. Above you have some tension T. So below you'll have some tension T plus dt. Hence the net tension on this will become dt,
Yes, sir.
Yes, sir.
right? Now, uh, what is the weight of this acting down? Already it is dm. It will be dm into g
Yes, sir.
dx into g.
Yes, sir.
Until this understood?
Yes, sir.
Now velocity should be independent of z. For this, now let me see. Your net force acting, which is there, is mass into acceleration, isn't it?
Yes, sir.
I'm going to take a steady state, so acceleration becomes 0. So sigma f net will become 0. So t plus t minus t plus dt, right?
Yes,
Minus
sir. Minus mu
is equal to 0. So let's cancel dt plus mu dx into g is equal to
0.
so from that your tension is equal to minus mu g into dx.
Yes, sir.
Now I know my tension mu into v square, isn't it?
Yes, sir.
Yes, sir.
So from that this will be dt is equal to v square d mu plus 2 mu v dv, isn't it?
Yes, sir.
He said velocity should be independent of your z, right? So this becomes your, so your dt will just become v square into d mu.
Yes, sir.
So substitute that here. V square d mu is equal to minus mu g dx. From this, d by mu is equal to minus g by v square into dx. Right?
Yes, sir.
So from maybe mu naught to mu 0 to z. This is log, isn't it?
Yes, sir. Log.
From this log mu naught by mu by v square into z. This is your answer. Is your answer matching?
The first option.
Yes, sir.
The whole thing is just take a small elemental strip. For that elemental strip, write your draw your FBD and then just go into the flow. You get here, from here you get stuck basically. So here dt means from here t is equal to v square will take. So dt is equal to v square d mu plus 2v dv into mu. But velocity is independent of your z, so it goes to 0. So because velocity will be constant, right? So dt is equal to v square d mu. Substitute that, you will get your answer. Next question.
So page number 60, question number 119.
The question.
Sir, a pop gun consists of a cylindrical barrel, 3 centimeters in cross section.
What is it?
Sir, a pop gun consists of a cylindrical barrel, 3 centimeters.
I'm writing the question, read slowly.
Okay. A pop gun, sir, pop consists of a cylindrical barrel, 3 centimeters square in cross section, closed at one end by a cork. Sir,
Okay. C-O-R-K.
and having a well-fitting
Well,
piston at the other. If the piston is pushed slowly in, the cork is finally ejected. Giving a pop. The frequency of which is found to be
giving a bob.
not bob, sir, P-O-P, pop. Pop, the frequency of which is found to be 512 hertz. Like the pop frequency is 512 hertz. Assuming that the initial distance between the cork and the piston was 20 meters, and that there is no leaking of air. Calculate the force required to eject the cork. Atmospheric pressure is 1 meter square.
1
1 kg centimeter square. Velocity is 340 meters per second.
340, yeah?
As-
Yes, anybody? Just tell me the approach, that's all.
So should we take it like frequency is
When you're talking, you're getting a V sound.
leaves? We are in the same class, so we are getting a reason. Okay. So is it like frequency is equal to V by 4N? Then we take the length out of it. So we know length is 25 centimeters.
Mm-hmm.
So then pressure is like directly proportional to length.
Yeah.
So it's PL is equal to P dash L dash.
Mm.
So we can find the pressure by that.
Mm.
After that, I don't know. Is it that's it, sir. I know.
According to Boyle's law, PV is constant. Okay,
Yes, sir.
understand the question. What he says is a pop gun, right? Not pop. Cylindrical barrel, area is given 3 centimeters. Closed at one end by a cork and having a well-fitting piston at the other end. So it will be like one end open, no? Or one end closed.
Open.
Then is pushed slowly in. The cork is finally ejected, giving a pop. The frequency found to be 512 hertz. Assuming that the initial distance between cork and the piston was 25, there is no leakage of air. Calculate the force required. So I'm going to go for Boyle's law because there is no leakage of air, and if you see your pressure is changing and your volume is also changing. So I'm going to take my Boyle's law. P1 V1 is equal to
P2,
V2. So
P2, L1.
length, okay, L1 is equal to P2 area into L2, right? So L2 I need. L1 is 25. L2 I need at 512.
So mu is equals to V by 4L.
Okay, tell me. What is it?
Mu is equals to V by 4L. So you can just find out L from that.
Mu is equal to.
V by 4L.
So from that L2 is equal to.
V by 4 mu.
Substitute that. From this, get me your P2 value. How much you got?
L is 16 centimeters.
One point five.
1.5. Oh, so this is your P2. We require force, no? We know force is equal to pressure into area, isn't it?
Yes.
Pressure is nothing but delta pressure into area. So it is P2 minus into area. How much is it? 1.5 kg weight, right?
Yes.
Understood the question and the way we have done it?
Yes, sir.
Yeah, if you don't mind, I'll cut the class now because I'm unable to speak. Is it okay?
Yes.
Yes.
Anyhow, tomorrow you have chemistry term exam, right?
Yes, sir.
Yes.
Yes, sir.
Prepare for that.
Thank you, sir.
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 Thank you, sir.